Welcome back. Let's do question 2. Given the arithmetic sequence, so this is an arithmetic sequence, determine a simplified expression for Tn. So we're finding what? We're finding the general term here for an arithmetic sequence. For an arithmetic sequence, Tn is equal to a plus n minus 1d. A is equal to 85, and then the difference 82 minus 85, that is negative 3. Right, so it means d is equal to negative 3. Can even check with 79 minus 82, still negative 3 there. 76 minus 79, negative 3. Then we substitute these into the general formula. So Tn is equal to 85 plus n minus 1, and then times negative 3. Please take note. Put your negative 3 inside the bracket, and then you distribute this. Right, so it becomes Tn is equal to 85, and then negative 3 times n, that is negative 3n. Then negative 3 times negative 1, that is positive 3. Then we can simplify this. What is 85 plus 3? That is 88. So Tn is equal to 88 minus 3n. Okay, 212. Which term will be the first negative number in the sequence? Right, we want to find the term that will be the first negative number. So what is happening here? The numbers are reducing, they are descending. So it means there'll be a time where we're going to be having negative terms here. Okay, so which term will be the first negative term? So we have to find n, and then from there we'll deduce which term will be the first negative term. So let's start by finding n. But we're saying now this term should be less than 0. Negative means less than 0. So we're saying our Tn, which is 88 minus 3n, should be less than 0. We're solving an inequality here. So negative 3n less than negative 88. Then we divide by negative 3 on both sides. And then remember, when you're dividing by negative, the inequality sign changes. N greater than 88 over 3. Let's write this as a decimal. This is like 29,33333, goes on like that. Remember, term number or n should be a natural number. Is it 29 or 30? It can only be 30, isn't it? So it means T30 is the one which will be the first negative term. 29, it means is still what? Is still on the positive side. We don't use the laws of rounding off here. Okay, you have to look at the context, right? So 29, the terms will be still positive, right? And then a 30, T30 is the one that is going to be the first negative term. Therefore, T30 will be the first negative term. Let's see what T29 is. T29, where there's n, we put 29. So T29 is equal to 88 minus 3 times 29. Okay, let's see what we get. We're getting 1. Let's see T30. We're getting negative 2. You see that? So it means T29 is 1, T30 is negative 2, T31 negative 5, T32 negative 8, going on like that. Right, 2.2. It says a quadratic sequence with the general term Tn is the following properties. T11, term number 11 is 190, and then Tn minus 1 is 4n minus 3, and our n should be greater than or equal to 2. Right. So we know the properties of a quadratic what? Sequence. Right. We have T1, T2, T3, T4, going on like that. Now the first differences, because this represents the first differences, Tn minus 1, like saying T4 minus T3, T5 minus T4, T2 minus T1, like that. So this represents the first differences, meaning that the general term for the first difference is what? 4n minus 3. It's going to be 4n minus 3, like that, right? And then we're going to have what? Our second difference is here. So we have to remember that the first differences for a quadratic sequence are what? Arithmetic or linear, right? So it says determine the first term of the quadratic sequence. We want to find what? We want to find the first term of the quadratic sequence. We're told that n should be greater than or equal to 2. So it means our first term, we're going to put 2 where there's n. But this is for the first differences. But let me use different notation. Let me say P2 so that we don't confuse this. P2 will be P for the terms in the first differences, right? And then P2 will be 4 times 2 minus 3, which is equal to what? Which is equal to 5. And then P3 is equal to 4 times 3 minus 3, which is what? Which is 9. Then P4 is equal to 4 times 4 minus 3, which is what? Which is 13. Okay, it goes on like that. So it means for the first differences, we have 5, 9, 13, going on like that, right? So we can find our second difference here, meaning that our second difference is 4, isn't it? Our second difference is 4. Now we have more information here. So from this, we know that 2a is equal to the second difference, which is 4, meaning that a is equal to 2, right? And then what else do we have? Right, remember, Tn is equal to a n squared plus bn plus c. Right, we're given that T11 is 190, and then already we have a. So T11, so we'll say 190. Then where there's n, we put 11. Our a is 2, is 2, and then 11 squared plus b. We need b, okay, we need b. So we can find b from this. We equate this to 3a plus b because we have a. So let's find b. Let's do it here. So 3a plus b is equal to 5. And then our a is 2. So 3 times 2 plus b is equal to 5. Then b is equal to 5 minus 6, which is negative 1. So we have negative 1 here. We need negative 1 here. So b is negative 1. So negative 1. And then n is 11. Then plus c, right? And then we can solve for c here. Okay. This is 190 is equal to 242 minus 11 plus c. Then we transpose this, we'll get that negative 41 is equal to c. So therefore, Tn is equal to 2n squared minus 1n minus 41. This is our general term. Okay. Then the question said, find the first term of the quadratic sequence. So T1 is equal to 2 times 1 squared minus 1 minus 41. Okay. And then what do we get? We get that T1 is equal to negative 40. So our first term is negative 40. Right, 2.3. The sum of the first 50 terms of an arithmetic sequence is 1275. Calculate the sum of T25 and T26. Right, we have to remember that the last questions of each question most of the times is level 4, level 3 there, where we need to recognize and use logic. Okay, so now we're given that the sum of the first 50 terms of an arithmetic sequence is this. Remember the formula Sn is equal to n over 2, then 2a plus n minus 1d. Okay, so we're finding the sum of the first 50 terms, which is 1275, and then our n is 50 over 2, that becomes 25, isn't it? And then 2, we don't have our a, and then plus 50 minus 1, 50 minus 1, then times d. Okay, 50 minus 1 times d. Let's simplify this. 1275 is equal to 25, and then 2a plus 49d. Right, okay. Let's check here. If we divide by 25 both sides, 1205 divided by 25, we get 51 is equal to 2a plus 49d. Interesting here. It says the sum of the first 50 terms of an arithmetic sequence is 1205. Calculate the sum of T25 and T26. T25 is actually A plus 24D. Then T26 is equal to A plus 25D, right? And then if we add these two, we say A plus 24D plus A plus 25D, what do we get? We get 2A plus 49D. See that? So it means T25 plus T26 is equal to 2A plus 49D. And then our 2A plus 49D is equal to 51. So therefore, we can say T25 plus T26 is equal to 51. Okay, because both T25 plus T26 and 51 are equal to 2A plus 49D.